Hello, YouTube. I want to talk about just I want to talk about something that no one else ever seems to talk about. So, distance to the horizon, 5 kilometers. We're gonna do things in metric because it's just better. 5 kilometers to the horizon, okay? And then right now, here where I am in America, have sunrise at 7:30 and sunset 6:13. That's for today. Right there. It says today. Today, February 11th, 2025, rose at 7:30 today, and it's set. It's dark now. It already set. It's set at 6:13. So, or that's well, I guess this I'm making this video after midnight. So this is for the 11th. It's 2 a.m. It's 1:30 a.m. for me right now. So, this is for today. It has not set yet. It hasn't even risen yet. But it'll rise at 7:30 and it'll set at 6:13, okay? That's 10 and a quarter hours basically. 10 I'm sorry, 10 hours and 43 minutes. Here it is right here. 10 hours and 43 minutes. So distance to the horizon is 5 kilometers. That means the distance from horizon to horizon is 10 kilometers. So 10 hours and 43 minutes to go 10 kilometers, okay? That's our math equation. 10 hours and 43 minutes to travel 10 kilometers, okay? We'll go to the calculator and we'll round it off to 45 minutes. So 10 hours, 10 and 3/4 hours basically, divided by, oh yeah, wait, we have to show this too. We have to show this. Here's our equation. Distance over time will give us the speed that it travels over that distance, over that 10 kilometer distance over 10 hours and 43 minutes. So back to the calculator. We'll start over. 10 and 3/4 hours divided by the time. Or I'm sorry, it's distance. It's 10 kilometers divided by the time. Divided by 10 and 3/4 hours equals 0.93 kilometers an hour. Okay, so 0.9 kilometers an hour. 0.93 kilometers an hour. You can almost just say that's 1 kilometer an hour. Not quite. So, if we've got 0.93 kilometers, it's traveling 0.93 kilometers an hour to get across 10 kilometers. let's see here. Earth's circumference in kilometers is 40,000 kilometers. 40,000 kilometer circumference. 40,007. Okay. Maybe you see where I'm going with this at this point. So 0.93 to travel 10 kilometers. It took almost 11 hours for this. It will take once it's risen up, the sun will take almost 11 hours to go at the speed of almost 1 kilometer an hour to go 10 kilometers. That's it, 10. It'll take almost 11 hours to travel 10 kilometers today. So, between the time when it sets tonight and then when I see it again in the morning and it rises again, how fast is it traveling then? So we've got 40,000 kilometers minus the 10 that it took the 11 to travel, that it basically took 11 hours to travel. So we've got 39,990 kilometers. That's our distance. So the other 13 and like a quarter hours that it takes to travel this 39,000. So let's go back to our equation here. Right? Our formula, distance over time. So here's our distance divided by 13 and a quarter hours equals 3,018 kilometers an hour. Let's check that. Times 13 and a quarter. 39,990. So how do you explain this? How do you explain the sun taking 11 hours to travel 10 kilometers at the speed of 0.9 kilometers an hour, and then moves up to traveling, what was the number? 3,018.11 kilometers an hour to make up the other 39,990 kilometers for the next 13 and a quarter hours. Can anyone explain how this makes any freaking sense at all? How I can see the sun travel 10 kilometers in my field of view and then speed up for the next 13 hours to make up for the rest of the 40,000. Like, the view is very small. That 5 kilometers is 3 in miles. It's 3 miles in the royal system. Or whatever it's called. The The imperial system. The imperial system. So so across 6 miles. So why does it take so long to get across the 6 mile field of view that I have, and then speed up, and it speeds up for the rest. So like, but no one else is seeing it speed up. It's just it's just the math is saying that it is. But how does that make any sense? It just doesn't make sense.